everyone. Now we're going to start looking at 3D shapes. Okay, we've got a lot of different 3D shapes. You see, these things are like boxes. We also have triangular ones. We have cylindrical shapes. And then we have the ones that come to a point. You've got a square bottom and it goes to a point called a pyramid. You have here a triangular one that goes to a point. And then of course we have the ones with the circular basis that go up to a point, and these are called cones. So we have a lot of different kinds of 3D shapes. We have polyhedrons, which a polyhedron is a general term for a solid with many faces. So like here's a shape that is a polyhedron that we probably won't even work with, but you will notice this is kind of unique in that it has 6 faces that all have the exact same shape, but the shape is not equilateral. And so therefore it doesn't fall into something that would be like a platonic solid. So today in the first part of homework 7, which is going to be split over 2 days, the first day of homework 7 is all made up of worksheets. So I will give you the worksheets in class. For those of you that miss, I'm going to send them out over Blackboard. So you're going to have 2-day work on this one lesson. That's why it's worth 20 points. You might have wondered that. Okay, so the first day, you're just going to explore the shapes, look at the shapes, name the shapes, look at the ways that distinguish these shapes one from another. And then on the second day of class, we're going to look at the actual surface area involved and the lateral surface area involved in all of these shapes. So we've already kind of listed them, but let's actually look at them by name now. Your general term for these are called polyhedra, all except for the circular ones. Your circular polyhedra are not polyhedra because they're not planes. A polyhedra, or plural, this is the plural, polyhedron is the singular. Okay, what are they? They are a solid figure with many plane surfaces or faces. Sure you can see that word faces there. Yes, you can. Okay, so polyhedra are many plane faces. And if we analyze this word, the word poly means many. The word hedra or hedron means faces. Regular polyhedra are named platonic solids. So these are a special kind of a polyhedra. Okay, we also have these are polyhedra. On the other hand, you have 3D shapes, and the difference between the polyhedra and the 3-dimensional, maybe I better write out that word dimensional. 3-dimensional shapes, shortened to 3D, are the inclusion of the circular. Okay, so this includes the circular when we talk about 3D. So let's talk first of all the various polyhedrons. So if we have the various polyhedrons, you have prisms, and prisms have two congruent bases. In other words, the bases are the same size and shape, congruent, named according to the base, dimensions are length, width, and height. And also sometimes diagonal distance. Okay, the next one would be pyramids. Pyramids have only one base they're named according to the base. Dimensions of a pyramid are length, width, height, and slant height. Okay, let's erase that. But before we do, let's look at a few of them. Here we have a prism. You see, it's like a box. It's a prism. This is another prism, and they're not the same shape or the same size. On this one, my base, see my two congruent bases? And in fact, I could use any one of these sides as my base. Okay, this one here, all of them are the same size, so therefore it wouldn't matter which one you chose on that one. Here is another prism, and this one we would use a triangular prism. See the two congruent bases, and because it's an equilateral triangle, all the faces are the same size and shape. Okay, so this is what you decide what the base is. Anytime you have a triangle, I would always use my triangle as my base on that prism. Okay, now let's look at pyramids. This would be a triangular prism. Even though this one is completely equilateral, it actually has another name, and we'll talk about that later. But notice the difference between your prism and your pyramid. Your pyramid goes to a point on the top. Okay, and then look at this one. Here is another pyramid, and notice the point on the top. The base is almost the same size as the base of this square prism, and this is actually a square, because the base is square, pyramid. It goes to the point on top. Okay, so that helps you to see what those are. Going on with these 3D. Now those first two were the polyhedron, the prisms and the pyramids. Now we're moving into the ones that would be under the category of 3D. 3D is a larger category than polyhedra because 3D includes the polyhedra and the circular 3D shapes. So now we're going to look at the ones that are only 3D and not polyhedra. So let's look at those. We have cylinders, cones, and spheres. Okay, cylinders have two circular bases dimensions include width, which would be called the diameter, and then half that would be radius, because you're going to use maybe both of them, width, radius. Remember, diameter is all the way across, and radius is half of it, and then height. If we're talking a cone has one circular base, dimensions include width, which is your diameter or radius, height, and slant height. Spheres compare to a ball. The dimension used is the radius, which is 1/2 a diameter. Okay, so now let's talk and show these last shapes. Okay, as we look at the circular ones, let's start with the cylinder. Here's your cylinder. You see your circular, your two circular bases, and then the height of this thing. If we cut this open and lay it out flat, it will become a rectangle. So you could see that on that. Okay, let's look at a cone. We have a lot of different ones. Let's hold up this one. Here's our cone. You see your one circular base, and then the slanted, the top. Okay? And we will talk about those things on that. And then let's look at a sphere. And I don't have a little sphere out of paper, but here we go. Here is a sphere. You see it's like a ball. I took two half spheres and held it up and put it together. And that would be your sphere. It's like a ball. And we will talk more about these as we look at them even more as we go along. Okay, so that takes care of all the names that are involved in this. In these 3D shapes, and I'm going to use 3D because of the need to include both the polyhedra and the circular shapes that we're dealing with on these. In these 3D shapes, there are certain things that you're going to be dealing with. The first thing is you're going to look at number of faces. You're also going to look at number of edges and the number of vertices. And these are going to be important things that are used to help you determine things. So let's look at this, and let's look first at the faces. I think I'll use the paper ones. They're easier to see on that. Okay, as we look at this prism, the number of faces we have, you have the bases, 2 of them, and then we have 1, 2, 3, 4 faces that go in the lateral area. So we have 6 total faces on this particular prism. We also have the edges. The edges are where 2 faces come together. So on the top we have 1, 2, 3, 4 of them. On the bottom you have 4 more, making 8. And then going around the side, you have 4 more, making a total of 12 edges on this particular prism. This is a rectangular prism. So we'll just put this up here for what we've written down. Faces, we have 6. Edges, we have 12. And then the vertices are the corners where all the faces come together. So we have 1, 2, 3, 4 on the top, 1, 2, 3, 4 on the bottom. So this one has 8 vertices. So that's going to be one of your tasks, is to actually do this. Before you actually work on these worksheets though, I am going to give you in class paper nets that you can cut these out, put them together, label one of them so you can see what the names of each one of them are before you cut. Then you put them all together and tape them together so you can actually have these shapes to look at as you work on the worksheet. So all of you will get those nets, okay? Let's look at a triangular prism. Okay, triangular prism. Again, notice your 2 bases and your 3 lateral faces. So we have 5 faces on this one. as we look at the edges, you have 3 at the top, 3 at the bottom base, that makes 6, and 3 going around it. So we have 9 edges. And then as you look at the vertices, 1, 2, 3, 1, 2, 3, making a total of 6 vertices. Okay, now let's look at a square pyramid, okay? That's what this is called. A square prism, a square pyramid. Okay, so looking at the square pyramid, we have 1 base, so that's 1 face, 1, 2, 3, 4 triangular faces around. So this has a total of 5 faces. Now let's look at the edges. 1, 2, 3, 4 edges at the bottom and 4 edges coming around the side. There's 4 edges and 4 edges, making 8 edges. And then your vertices, you have 1 on top and 4 on the bottom, making 5 vertices. So you can see they're different from each other. Let's look at the triangular pyramid. Okay, when we look at the triangular pyramid, you've got a triangular base and then 3 triangular going around on your triangular pyramid. So that makes 4 faces. And then your edges, you've got 3 at the bottom, 3 around the top, making 6 edges. And then if you look at your vertices, you have 1 at the top and 3 on the base. So there, that makes 4 edges, vertices. So as you can see, they're different from each other. Now, the cylinder doesn't have faces other than you might think of the 2 circles at the top and bottom might be faces, but you can't count them as faces usually. You could maybe, but this curved face, you can't count it as a face because it's not flat, it's curved. And so we do not usually do faces and edges and vertices. And because all edges have to be a straight line, none of the circular edges count. And there's no points, so therefore we don't have any vertices either. You might have 2 faces at the most on a cylinder. If you move to a cone, on the other hand, you might have 1 face for the circle at the bottom and 1 vertex, but nothing else counts because you have all circular edges, so they're not an edge at all. They have to be flat or a straight line to be an edge. You've also got other shapes you can look at, like this one, which has a hexagonal base, and you will notice this one happens to be a regular hexagon, and so therefore all of the sides of this regular hexagon are exactly the same size rectangle. We have our 2 bases, and then you have 6 faces on the side, making a total of 8 faces. So as you see, the number of when you change a shape to a larger and larger polygon with more and more sides on that polygon, then it increases dramatically the number of faces you have. It also increases the edges because this has 6 and 6 and 6, making a total of 18 edges. And vertices, again, you have 6 on the top and 6 on the bottom, making 12. So it increases it dramatically when you move into larger sided polygons. So this is really kind of fun to look at how all these things vary and change. And a sphere, you have absolutely no possibility of faces, edges, and vertices because it's completely rounded. There is no such thing as those particular surfaces on a sphere because everything is curved on a sphere. Therefore, you have no possibility of any kind of a vertice, edge, or face.